We need to have these valueless wholes. Welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to really think about pedagogy, teaching and learning, professional development, anything of interest to time-poor but enthusiasm-rich primary teachers. This week, I'm joined by Christopher Such.
Hello again.
And together we're going to explore fractions. But first, Chris, what you reading for?
Hey, what you reading for?
Just today, I was exploring a paper called, I'm going to read this because it's slightly longer than I remember. So, Testing in brackets, Quizzing Boosts Classroom Learning, a Systematic and Meta-Analytic Review by Yang et al. From 2021. And it does what it says on the tin. It's a review of lots and lots of research relating to the testing effect, quizzing, but particularly relating to classrooms. It looks at 222 independent studies with over 48,000 students. And there are some kind of key takeaways about quizzing that I was sort of semi-aware of, and some that I was completely ignorant of, and some that I already knew. So, you know, the key thing from this is, yes, testing benefits learning. You know, testing seems to be a beneficial thing to do. What's interesting is the nuances. So, for example, there doesn't seem to be any impact of the stakes of testing or the means through which you do the testing. So, you know, whether you're using multiple choice questions or using something that requires a little more difficulty to retrieve, doesn't seem to make a difference to outcomes. And I'll talk a little bit more about that in just a moment. It is, a really fascinating paper to dig into if you're interested in this stuff. I think the most interesting parts were about the theories that it says are supported or are not supported, or supported to a lesser extent by this. So there are certain theories behind the efficacy of testing that they define as additional exposure, which is just you're doing more of it, so it's bound to make a difference. And there seems to be some backing for that. Transfer appropriate processing is the second theory. And this is the idea that the kind of questions that you answer will be similar to the kind of questions that you might be exposed to when testing, and then assessment as well. And so the consistency between those might be useful. And there seems to be some suggestion that that's part of the reason behind the positive aspects of the testing effect. There seems to be less evidence related to like retrieval effort. So the idea that you're putting like it's quite a challenging thing to do, kind of, you think about in desirable difficulties terms, there doesn't seem to be as much backing for that as the reason behind the testing effect, which I found interesting because I would have assumed the opposite before I came to this. And the fourth theory, which it says there is some backing for, is just the idea of the impact of it on motivation. So the way that it makes you think, oh, I got this wrong and I now want to learn it to find out why I got it wrong, or I retrieved this and I got it right, and there's a little boost to motivation that way. So those were the theories and why it's particularly interesting. The very last thing I'd like to mention is that I learned a ton of stuff through being lucky enough to read about this and talk a little bit about it with Nick Rose, one of the pleasures of working where I do. And he talked about the ways that the ways that researchers can test for publication bias, look to see how robust the findings are. And yeah, it was really interesting to learn about that stuff too. And I think you can infer some of this stuff from this paper because it does it quite well. So yeah, wonderful, really fascinating paper, well worth kind of half hour, 45 minutes of your time to pick apart. Yang et al. Testing, Quizzing Boosts Classroom Learning, a Systematic and Meta-Analytic Review. Check it out. What about you, Kieran? What are you reading for?
You weren't lying when you said you could talk the whole episode about that paper. But it sounds really interesting. And I think I'm definitely going to check it out sooner rather than later. I have been reading a book called Tried and Tested, and it's by, and I'll butcher the names as usual, Wendy Adeniji and Juliet Park. And essentially, it's about modern foreign languages at primary school. And, do I agree with everything in the book? No. But am I less experienced at teaching modern foreign languages than the authors? Yes, definitely. So I think if you are thinking about how you're going to improve modern foreign language across your school, then it can't hurt to start with this book, because there's a lot of food for thought. And while I've never seen a class of year 6 who were proficient in another language other than English, unless it was their home language, I really wish we were in a position as a country, or certainly as an English-speaking world, where it was more normal than it is. Because one of the downsides to English being the language of business, the lingua franca, so to speak, which I always find really ironic, is the idea that you don't necessarily need to learn another language to get by in the world if you know English. Whereas that's not true. And I think your life is much richer for understanding other cultures and other languages, and I wish our children had that opportunity. So anything that can take us in the right direction is worth checking out. And so I find it really thought-provoking. I agree with lots, but also some things I'm going to revisit.
Sounds really interesting. I think it's a neglected area of the primary curriculum in terms of teachers' knowledge. So great to know that there's a book on the subject that we can turn to.
So this week, Chris, we're going to turn our attention to fractions, in one of those episodes where we really get under the skin of a very small part of mathematics, some of my favorite episodes. It probably won't be enough to cover all of fractions in one go, but I think we can really start to prod what fractions are. And my first question, what makes them tricky?
I think a lot of our teaching, if we think about the introduction of fractions, starts off with a pictorial representation. And certainly that's where the national curriculum begins. And the nature of it is that there is this implicit idea when we're talking about 1/4 or 3/4, and there's nothing after that. It's just 3/4 as a thing. There is this built-in idea that we don't necessarily communicate to children for obvious reasons at first, that this is 3/4 of one thing, which we take for granted. But again, when children later down the line start to deal with 3/4 of 20 or 3/4 of 10 or whatever it might be, they then have to kind of convert. I mean, they've spent a lot of their time understanding fractions as dealing on some level with parts of a whole thing, and then to transfer to, oh, okay, this applies to collections as well. How does this work? I think that's one of the key difficulties. There is like an inherent multiplicative relationship, obviously, within fractions. When we're talking about 3/4, where often you'll teach them in certain ways, and for a student to find that you can think of 3/4 as one divided into 4 equal pieces and then count 3 of them, but they can also see 3/4 or can work out 3/4 as 3 whole ones divided equally by 4, and that those two things automatically lead to the same place. I think that's a really challenging thing for children to wrap their head around, that there is effectively this underlying multiplicative relationship that is relative to 1 that is a fraction. So yeah, I mean, those are the key things I'd say. I'd also just say that children get used to numbers being a way of representing a set of objects. And as soon as you're then saying, okay, this thing, which is kind of a set of objects, I guess, or parts of an individual object, is now being represented by 2 numbers, or should I say 2 digits, or perhaps more digits in reference to each other. And they're introduced to the vinculum as well, that line in the fraction. It just becomes an exceptionally complicated thing to deal with.
It's interesting how you've interpreted that question, because I've thought about other factors that make them difficult. We thought about the inherent difficulty of fractions. And I think if I, for a second, consider why they themselves might be difficult, I think it is that idea that, you're building up your understanding, your schema in relation to number, and it's predominantly, if not exclusively, whole numbers. And so it's almost a question of when do we introduce the idea. Is it sufficient that we introduce it maybe in year 1 or 2, depending on where you are, or should we wait later? I don't know. But like when I thought about what makes fractions tricky, I thought, well, typically we don't spend enough time really embedding the sort of fundamental concepts or the fundamental ideas associated with fractions. And so then every other piece we try to add is less secure. The hook isn't as robust as it might be, as we'd hope. So maybe not enough time to play with fractions. When we talk about Cuisenaire rods, how often do we allow children so much time that they've got this really implicit understanding of the relationship between them? I reckon you could ask most teachers and they'd be able to talk about the relationship between the white, red, and green. But from there, I don't think, I think more time is needed. Sort of linked to that, our own understanding rarely goes much further than the year we're expected to teach. And I don't think that's a good base position to be in, because the more rounded our understanding of the concept, the more clear the pathway from that first introduction to, let's say that it rarely gets more complex than GCSE, and then the complexity isn't because of the mathematical idea, but because of the utilization of the idea. I don't know. Secondary teachers are probably screaming, going, no, it's much more difficult at A level, but I'm happy to stand corrected on that.
I think something you mentioned there kind of jumped out at me as well. When I've been working with pupils on the idea, the basic concept of a fraction, and you're using something like Cuisenaire rods, it's, again, there's a fundamental difficulty in there, in that often we'll show children fractions by saying, like, here's a thing and I'll draw on it, or I'll break it into pieces, and here is thus 1/4 of this thing. And yet equally with Cuisenaire rods, if you choose the one that is kind of 8 times a single unit and one that's 2 times the size of the single unit, and you can compare them, you can say, well, this one is 1/4 of the length of that one. So there is immediately from the very beginning of discussing fractions, this sense of comparison between 2 different things, as well as it is an amount of this thing. So yeah, I think that's something that makes it particularly challenging. Or even just going back to the visual representation, say you draw a circle and you divide it into 3 equal pieces, and then you color one in and you say, well, this bit here is 1/3. The rest of that thing is still there, and for children who are still often coming to terms with the idea of counting objects, to say, well, what do you mean 1/3? That whole thing is still there. It's just that colored piece is 1/3. Well, where's the rest of it gone? Why are you showing me the rest of this thing? Because you need to show the rest of the whole thing for them to be able to see what this 1/3 or this 1/4 or this 1/2 is. But the fact that it's still there means that, like, trying to pin down exactly what the 1/3 is and what the whole is particularly challenging conceptual thing for children to wrap their heads around.
That, I think, ties into one of the key points. I mean, you were very kind to sit through my talk at Research Ed Berkshire, where I explored, maybe 65 plus papers into the use of manipulatives. And one of my big takeaways was that the more salient a representation, the more difficult transfer is. And I think that's a trap that Cuisenaire can very easily fall into, like you described. When it very clearly represents one thing, how quickly can we, or how easily can we transfer that idea that this represents something different as well?
Brilliant talk, by the way. I mean, if anyone gets the chance to see you talking about manipulatives, it's, worth the price of admission alone, in my experience. Not that I had to pay. As it turns out, I was there. It was a freebie, but I would have paid. I promise, Kieran.
I mean, that's very kind of you to say. I've actually submitted it for the ResearchAid National Conference in 2022. So fingers crossed, I'll be able to deliver it again in September. Thinking about what makes fractions tricky. In what way is language an impediment or a support in the teaching of fractions?
I think there are things we can do to make the language that we use as supportive as it can be. But in terms of where it's an impediment, there's kind of some obvious stuff that jumps out at me. So the fact that we talk about halves, we mentioned halves and quarters here, that is not ideal. Thirds instead of threeths. I mean, threeths would be convenient. But yeah, so once we get to sevenths, eighths, ninths, etc., we're fine. But with the most common fractions that children are going to use, we have that issue of having to kind of explain the words we're using. There's not this nice self-evident pattern for the first few of them, which I think clearly makes things more difficult. I think also when we're talking about what 3/4 is and what the different things it can represent and the way that it can represent this multiplicative relationship related to 1, the fact that we can talk about it as 3 parts out of 4, but also as 3 whole ones broken into 4 equal quantities doesn't make life particularly easy, that it has that kind of double meaning and the language related to that. I think one of the hardest bits though is the word of. I always come across this difficulty in children working with this, because of course, when we're talking about multiplication and we say 3 lots of something, perhaps, or say like 3 lots of 4, there's embedded in this idea of and lots of that we're talking about starting with 1 and then, or a certain amount, and then counting groups of them. But then when we go into like 3/4 of 10, we don't say 3/4 lots of 10 because it doesn't quite fit. There's something about this word of that suggests we're taking something from within something. We're taking a smaller piece of a whole, which is fine, you might argue, until you then get into, say, 9/4 or 9/4 of 10, say, because we're talking about not taking like chunks of something smaller. So the language gets really quite confusing around of. And so we end up with these circumstances where we say to kids things like, if in doubt, of means multiply. Just as long as you bear that in mind, you'll be okay. But again, it's not ideal that we have this double meaning or this double use of this particular preposition.
I mean, that was the very first thing I wrote down. Some of the ones I always think about, well, like when there are 32 parts, what do we call that? It's not a 32th or a 32nd, 21, lots of our numbers don't conform, and don't help us with fractions. And where a language allows you to be more effective, just like when we're talking about place value, you're impeded by the fact that it takes a lot, we want to be succinct. We want to be really clear in our mathematical vocabulary choices, because if we can say something in 2 words that might normally take 10, then we're allowing pupils the chance to consider what it is they're explaining, because they've got access to vocabulary that says more in less time, if that makes sense. I don't know if I'm going around circles.
There are certain ways where we look at our language and we say, no, we can't change it for really good reasons. So for example, with our spelling system, there are, because of the etymology of the words in our language, the history of them, and because of our spelling system that comes about because of that, it's quite complicated. But trying to then say, oh, we're just going to make a simpler version of it doesn't fly because of all sorts of reasons, including things like different accents that will pronounce things in different ways. So finding a uniform way to spell stuff is, basically a non-starter. And yet, when it comes to whole words and definitions of words within things like mathematics, I'm a bit more radical. I'd be perfectly happy to say, for example, no, we stop using the word quarter and we start calling it a fourth, That's sensible, for example. I mean, the challenge there would be half. Presumably, part of the reason that's come about is because tooth is already a thing. And so, yeah, you'd have ways around that. But I'd rather deal with that than all the, halves, thirds, etc. But there are ways, however, in which language is on our side rather than an impediment, or can be on our side if we use it carefully. One thing I often have seen when I've watched other people teaching mathematics is, and particularly related to fractions, is the way that they use numerator and denominator, and the fact that often there's this reluctance to use the words, and so they end up using both for basically all of primary education. They'll say, okay, so the top number, which is the numerator, and the bottom number, which is the denominator, which is perhaps fine when you're introducing it, but at some point you have to commit. You have to say, no, I'm just going to call this the numerator now, and I'm going to call this the denominator. Otherwise, I'm not getting the value out of the fact that I have this relatively simple label. So I think some things that we can do to support the teaching of fractions is to commit to these useful labels. And perhaps, dare I say, this is my bias coming to show here, perhaps look at a little bit of the etymology of the words, look at the fact that we have this kind of num part of numerator suggesting counting, and we have this nom part suggesting that it's like the name of the fraction in some way, which I think is often helpful to pupils. So I think there are bits and pieces that we can do to when it comes to language to support pupils' understanding.
Yeah, I mean, I was going to suggest that in this instance, etymology is your friend, because I think the original word or the origin is denominare, to name, and once you sort of explore relatives in that area, like denomination, you may have already learned about money. Well, I'm not sure how often we talk about denominations of money, but it's an easy connection to make when you say, well, here is a set that you will understand, and here's something, and here's a way we use it in this context. And I want to say numerare, but my pronunciation is way off. It's been thousands of years since I studied Latin, and I really should get back into it. I think that happens all throughout mathematics. The 15th century, ministers / mathematicians, as they were, chose a lot of the symbology and the vocabulary and the terminology for very particular reasons. The multiplication cross, is a cross. It's sometimes, a lot of the times, it's a dot, but it's a cross because it's Sanander's cross, and Sanander is reportedly the person who brought Jesus the loaves and fishes, which were multiplied. So some sort of Anglican minister / mathematician in the 15th, 16th century has decided that would have a lot of resonance, and it's a story that can bring a hook to to that your exposition at the start of a lesson, or your introducing multiplication, and certainly in terms of the product. And I think if you can find something similar with numerator and denominator, then they become really useful terms, because you can't spend 4 years going the top number and the bottom number. It's just cumbersome.
I mean, in some ways, I think if a school kind of makes the commitment to one or the other and say, you know what, we're just going to call it top number and bottom number, that is a better deal than trying to constantly deal in both, or not having a level of consistency. But from my experience, children are actually much more adept at picking up regularly used vocabulary than we might suspect them to be. So just throwing it out there and say, no, this is the numerator, this is the top number in a fraction, we're going to use the word numerator from now on, and this is the denominator. But linked to that, I mean, I have to say, I'm currently tutoring a friend's son, and part of what we're looking at the moment is fractions. And this idea that the denominator is, to some extent, the name of the piece that we're dealing with has been a particularly valuable way of talking about fractions. But alongside that, having language like, if you're talking about 3/4, saying, well, we can also think of this as it's 3 parts out of 4, it's or 7/8, it is 7 parts out of 8. And using that kind of language is something I think we sometimes forget to do. I think we just forget how tricky it is to learn fractions, actually.
One thing that I haven't heard for a long time is the idea of vulgar fractions. We hear about units, non-unit, improper, but whenever I was learning about fractions for the first time, the term vulgar fraction was pretty common. It might still be common in secondary schools, but because that has such a really strong resonance as a word in other contexts, if something's vulgar, it's not very nice. So you almost get this negative reaction to it. And certainly if you're of high sensibility, I don't know. As I'm speaking, it seems less of a strong word, but vulgarity is not something one wishes to aspire to. So it's good that we can see things that aren't existing anymore. And if schools are willing to sort of front load the vocabulary, say your year 3, and you start throwing the terminology in, then you might put yourself in a good position so that by the time you really need to understand them in year 5, you've got a handle on them. And some people will record the fraction in a different way that suits how we say it. So a fairly typical way to do it would be to write 3/5 as 3 line 5. Well, actually, the total number of parts is 5. Of them, 3 are important in this context, and then you're almost sort of encouraging people to think in the right way. But I don't think that's common. And when I say to them, oh yeah, that's great, I must do that, and then I forget about it, and now I'm thinking, right, okay, this is the day that I go back to doing that.
You've just reminded me of one of the most annoying parts of teaching fractions, and anyone who works in year 5 or 6 will recognize this. We spend half our lives trying to get pupils to write one number per box, and then we get to fractions and you're like, well, how do we write mixed numbers with one number per box? Do you go with the numerator and denominator getting its own box, and suddenly the whole part of that mixed number is massive, it takes up 2 lines? Or are you going with the squeezing numbers into boxes? There's no good way. I almost wish that there was like, no, we have special paper for fractions, or we just use blank paper for fractions, because every year that's something that ends up with like pretty ugly presentation, or can do as a result. Yeah, not the most important part of teaching fractions, but for someone who's as pernickety as I am, yeah, that was always a difficult thing to take. Let me throw a question over to you, Kieran. Where should we begin with the teaching of fractions? And does the national curriculum, where it begins, does it help us? Do you think it begins in the right place? What's the progression like in terms of your ideal of teaching mathematics?
Yeah, so I think fractions in the national curriculum is almost your archetypal example of ministerial interference. Certainly the stories that I've heard recounted over dinner and things have been very much a case of, well, it wasn't there originally, but then we were told that it had to be there. So, that's why you get this very dense clump of fractions somewhere, like I say, somewhere around year 5, year 6, where, Charlotte Hawthorne has provided me with a question for an upcoming maths conf. In fact, it might be the maths conf that goes out on the same day as this episode. And she's asking about unnecessary inclusions in the national curriculum. And her example was, the inclusion of fractions, which she says most secondary teachers would probably prefer we didn't do. So in terms of, is the national curriculum helpful? Because the experts don't appear to have been listened to, I think it's certainly less helpful than we might hope. Those bits of fractions are some of the most enjoyable to teach, as an adult, but I'm not convinced they're appropriate for the pupils that we're teaching. I think you've alluded to it a few times. Any consideration of fractions needs to be rooted firmly in this idea of the whole, because that's where things go wrong with ratio, because we don't make the connection with ratio as being the other side of the coin, essentially, to proportional reasoning. And if we start with this idea of the whole, and it's almost like a valueless whole, I think value comes in too soon. We need to have these valueless wholes that we can explore, cut up, put back together again, and then utilize as a connection we can make the whole way through. Then that's how we start, and it's also how we finish in primary school, because we're restricted to the fact that this is the national curriculum. But I think if you see ratio as a description of the whole, but just in a slightly different way, that's the bit that's normally missing. And that's the bit that a more robust exploration of the whole at the start might provide us with. And I would certainly have less attribution of value in Key Stage 1. And then maybe, I'd be satisfied if what is now explored in Key Stage 1, we maybe spread over a Key Stage 2 with more time spent on really getting underneath the 2, potentially 3-dimensional properties of fractions.
I think it's really interesting that you mentioned ratio here, because immediately I'm thinking about the classes of children I've taught in year 5, 6 who are confident, or who have arrived to me in year 5 or year 6, confident with fractions, and how easily they've taken to ratio when you've introduced it, and like, oh, so I can think of 2:3 as 2/5 and 3/5 of this thing. You're like, yeah, it's just that. And then suddenly ratio is just the simplest thing in the world to them. And it just pushes upon us the need to make sure that fractions are taught well, and highlights, as we say, the fact that the national curriculum probably isn't doing us any favors here. I think one of the things that bothers me most about the national curriculum, and maybe someone else will say, no, this is a perfectly good idea, etc. I worked in year 2 and I've done a bit of teaching in year 1. I think that introducing children to fractions initially and making it like a mandatory part of the curriculum and saying you will introduce them to a half and a quarter, and that's really all that you need to worry about. I don't think that's a particularly sensible way to do things. If that's it, you have to go beyond that. I think as soon as you are talking about parts of a whole, if you just do half and a quarter, you're 2 examples in effect, and then say, oh, well, then they're not ready for more examples than that. If they're not ready for more examples than half and a quarter, then they're not ready for any form of fraction. You need to immediately be talking about thirds and fifths, etc., and tenths, in order to get this idea of what these symbols are actually representing, how they work. I'd probably even go as far as to say that I wouldn't want to wait a whole year between introducing unit fractions and fractions that are non-unit, because I don't want children to have a whole year of an impression that there's always a number 1 on the top of a fraction, that we're always talking about something that's broken into a certain number of equal pieces and we're talking about one of them. It just doesn't quite fit for me. There are certain ways in which, we have to break up subjects. We want to have a sense of spiraling of the curriculum. Totally makes sense. But how you divide it up has to be quite sensible. And that kind of year 1 part there doesn't feel particularly sensible at all to me.
No, I mean, there are more important things we can be doing in year 1. With numbers 10 alone, you could fill the whole of those, what are they, 30 weeks in an academic year? You could fill those 30 weeks with just exploring numbers to 10. Obviously we don't, because we want to look at shape, space, and measures, and all the other things that are important. But to think that, you introduce this one glib idea and you don't come back until year 2, and it's not the most important thing you're doing in year 2, so you maybe color in some shapes, and then by the time you get to year 3 and you're starting to learn about division, well, you haven't really explored, one version of division or one representation of division to the extent that it'll help you. And I think, mathematics feeds itself. Really strong understanding here will make this bit more robust. One really weak understanding will bring that whole house of cards down. And so, yeah, we really need to think about the connections that we make and what that looks like over 7 years. Because like you say, if we just dropped it on, we are almost getting to the point where all we do is say, let's not teach anything in year 1 and 2. But yeah, do more in a more intense fashion because pupils are ready for it. And if you spent a whole year where you just went through unit, non-unit, multiple examples, you probably get more bang for your buck than what we have now.
Yeah, I mean, I don't think fractions are akin to, say, bar charts and pictograms and aspects of the curriculum that you really could, in theory at least, just leave until like year 5 and 6 and go, we've not done this before, but now that you have the actual numerical understanding that's required to grasp the basics, this is going to be dead easy to you. It isn't like that. It's not, or at least it isn't that extreme, but there are definite aspects that you could leave. I mean, I appreciate that you might want to be talking about fractions in real contexts from, even reception, where you're talking about, oh, can you fill that bucket half full of water, or this sort of thing, where you talk about real experiences. But the idea of like assessing pupils' understanding of fractions in year 2, that just doesn't feel quite sensible to me.
I think most people will do that naturally in the context that they set up, because you're never going to have, sharing cakes, you're never going to have a whole cake, but it's the minute when you put the expectation this must happen. So like, for instance, say you were exploring the idea of one-to-one correspondence. Some pupils might naturally develop a sense of cardinality during activities designed to explore the stable order. But the minute you start saying you have to understand the cardinal value of what you're counting, it then becomes, I think you lose some of what's possible, because you want to give people the opportunities to arrive at that understanding, because they've seen so many examples of counting, they've had their errors corrected. And I think the example you gave is the same. The minute you start saying you have to do this, well, then you lose a lot of the great stuff that you do that happens through the freedom to design experiences or tasks that allow for that kind of reason to take place. Because Mike Askew, he does the thing where you're comparing fractions, but it's in the context of, okay, we've got some friends, I baked some cakes or baked some cookies, and more friends come, how many cakes do I get? Fewer friends come, how many cakes does everyone get? That kind of thing. And so you've got this proportional reasoning, but there's not a written fraction in sight. So I think, yeah, I mean, I'm not one for groovy thinking, but I do think what you say is an example of where it's to the detriment of the experience of the pupils when we add the formality too soon.
Yeah, I think there's definitely an extent to which that by the time you are teaching them fractions, you want this to be a formal labeling system for something they've already got kind of an inherent grasp of because of the work they've done relating to division and multiplication, particularly using real objects, for example. So, I mean, the other thing I'd mention about the national curriculum is just in preparation for this podcast, I had a little look at the other year groups that I'm a little bit less familiar with or haven't taught for a while. Year 3, that's a real doozy. That's a real doozy. Like the fact that through that year group, and presumably in a lot of schools, all at the same, like in a chunk of time that will just be, we're learning about fractions and we're going to do this for the next, 3 or 4 weeks. There's fractions of amounts introduced for the first time, comparing fractions and adding and subtracting fractions. And that is a hefty set of stuff to throw at children that's kind of got slightly different bits of understanding underpinning it. So yeah, that's a tough year group. I always thought year 5 had it tough, but I think year 3, looking at it, have a pretty challenging job.
Yeah. So let's put our least experienced teachers there. That'll do.
Yeah, that's what. Year 3. Yeah, furthest away from any kind of summative assessment. That's where they can, in inverted commas, do the least damage. Yeah, that tends to be what happens.
Yeah, those inverted commas are doing a lot of work there. So, what are the strengths and weaknesses of different pictorial representations of fractions?
I've drawn myself a little table in preparation for this question. So I'm sure I won't take everything you've got to say because you know this stuff more than I do, but you never know. So let's start with the bar model. I think the first thing about bar model is its versatility, the fact that children will be using it for all sorts of other bits and pieces if it's a representation that your school uses. And I think it's such a valuable one that it'd be a good idea that your school does. So versatile, children will have seen it before. The fact that compared to other representations that we might talk about in a little while, that you can use the aspect of color quite clearly to represent amounts. The fact that you can find it on mathsbot.com, you can find it on Maths Learning Center, and that they're manipulable there really, really usefully. I think those are the key strengths of bar models. I'd say the weakness is that it can be hard to see what one is, if that makes sense. If you've got, say, several of them, you can see, okay, so that's a whole one and I'm breaking it into parts. But compared to, say, one we'll talk about in a minute, so a representation like a circle, it's hard to say, okay, if you take another chunk, another quarter, and you put it on to your whole one, it doesn't look like 5 quarters or 1 1/4. It now looks like one thing broken into fifths. So you have to be really deliberate with it when you're explaining to children what we're talking about in terms of one, and whether that means you're using some kind of grid reference, that's the wrong word. You want some kind of grid on which you're saying, look, this space between here and here, this is the size of my one thing. Usually from lessons I've done and seen, you're talking about it as a chocolate bar or something else you can break into pieces. Just a little aside there, doing my tutoring the other day, started using bar models for this, mentioned it, saying that, oh yeah, we can think of it. Let's imagine this is a chocolate bar. And the kid immediately jumped in with, why is it always chocolate bars? Why is fractions always chocolate bars? Oh, and pizzas. So yeah, he's right. It's always food for some unknown reason. But yeah, those are the strengths and weaknesses, I think. Versatile, kids will be used to it. There are fantastic online representations that you can use. The key weakness is it can be tricky to see exactly what is one compared to other representations.
Yeah, I mean, I think they're structurally sound in terms of the structures of arithmetic. You know, they really respect the structures, I think, in terms of, you know, more so than other representations. The fact that they're rectangular is really helpful because probably easier to get an approximate proportion. You know, you're never going to be precise, and any time spent asking pupils to be precise in this respect is probably a waste of time, because as long as it means what the pupil thinks it means, I think that's probably where I draw the line. But you're right, you need a lot of prior understanding to get the most out of them, because I always say they don't do the bar models don't do the maths for you. They just help you sort of, you know, take some of what's in your head and place it there for future reference. You know, was it the transient information effect? It's almost like an anecdote, or not an anecdote, an antidote to that. You know, this information is no longer a transient thought in my head. It's something that's here and I can manipulate it, I think, you know. But it has to be something you do from year 3 to year 6 to get good at.
When you're dealing with things like finding, you know, half of a quarter or finding 2/3 of a third, being able to draw in 2 different directions, that horizontal and vertical, in order to be able to show visually this idea of, you know, half of a third being, well, I've broken this into thirds using vertical lines. Now, if I break it into a half with horizontal lines, I can see that a half of this third I've broken it in effect into 6 pieces, and that I'm talking about one of them. So that there's that particular value to having this rectangular representation. I mean, how you would try and make that work with, say, a circle, I don't even want to begin to imagine that.
Yeah, probably also not a good idea with percentages, because if you try to draw 100 parts, I think you're losing some of the impact.
Yeah, I think if you're going for like 73% of 364 and you're trying to draw that as a way of finding out what's going on, then you could be there for a while. Having said that, we've all been there when we've seen a child answering a SAT paper and they've got a question like, what's 3/4 of 364? And you see them drawing 364 dots. And you're like, oh, goodness. Oh, please just go on to the next question. But yeah, that's perhaps for another. Yeah, that's for another episode. The scariest things we've ever seen when children are answering SAT papers is certainly an episode in itself.
That's an Elliot Morgan episode. That one is. What about the number line? What do you reckon? Strengths and weaknesses.
I like the immediate visibility of the whole, because you're labeling it, but also the immediate visibility of numbers of, say, improper fractions or mixed numbers, because you can immediately see, even when you're talking about 1/4, 2/4, 3/4, you can kind of look ahead to say, well, what's that there? Where's that going? So I think that's something that I quite like. I think also the fact that it subtly sensitizes children to the idea that fractions are numbers, and thus that we can also be thinking about them in a negative sense as well, which is not something that you immediately get from other kind of pictorial representations that, are obviously cardinal rather than ordinal. So yeah, those are the things I like most about them. I'd say the challenge to it is the same challenge that we have with the number line generally, which is that it is that bit more abstract. It's an abstract understanding. We're thinking about amount or quantity in terms of a distance from zero. The continuous nature of it is can be a bit of a challenge, but yeah, I think those are the strengths and weaknesses. There's probably one more weakness actually off the top of my head that comes to me. When you're looking at, say, 3/4 on a number line, you say, okay, so here's this position is 3/4. Usually you'll also have labeled on there whole 1, 2/4, 1/4, etc. You start to see, in the same way as you do with the number line when you're counting, you start to see this it's like embedded nature of other numbers. So you see 3/4 as almost, if you will, kind of containing 2/4 and 1/4 within it, in the same way that we can think of 4 as containing kind of 3 and 2 and 1. It's kind of nested idea, and there are obviously strengths and weaknesses to that, but it can be a particularly challenging thing for children to wrap their head around, particularly if they're not quite experienced with the number line itself.
Yeah, it's tough to do 50 minutes exclusively on the number line and find new stuff to say about it. I really like that it allows pupils to explore a sense of number in space, and it's a key driver in our mathematical understanding, or certainly, you cannot separate the internal number line from our proficiency with things like fractions. We said that before. I think the big issue is user error. And again, going back to before, we use it too early. We introduce it too early, and I think, there's a lot to be said. Everything you said there is, okay, that's what I want my pupils to understand when they leave primary school. It's just choosing the right time for that to be a thing. Now, we've mentioned circles a few times. Are there any positives for using circles with fractions?
Yeah, I think so. I think it makes the idea of the whole really clear straight away. If you've got like quarters, say, and you're piecing them together, it's very clear when you've got 5/4 or 6/4 that you have got a whole 1 and 1/4 or 2/4, depending on which one you're talking about there. So I think as an initial introduction to mixed numbers and improper fractions, I think they can be particularly useful. The downside is that we often just end up talking about them as pizzas and cakes. There's this tendency to see a circle and to go in that direction. I think also they're particularly hard for children to draw. If you say to them, can you estimate what a third is on a rectangle? You've got a pretty good chance that they're going to give you a pretty decent estimate. Whereas with a circle, they might have a good understanding, but their spatial awareness in order to draw that can be significantly more challenging. So in terms of assessment, in terms of assessing children's understanding, it can sometimes be a bit more difficult. Just something to note as well, we're talking about these particular representations, and I think what's worth adding on is the fact that we can often end up restricting ourselves to these when one of the most important things we can do is show children a wide variety. I remember in my NQT year being surprised by, I think I saw some SATs papers, and it was a few weeks before the SATs came around because I was a year 6 teacher, and noticing and realizing the variety of representations of shapes and the importance of children seeing parts within different shapes in different orientations, say. So yeah, as much as we're talking about bar models and circles and then number line, and these are kind of like some of the most common representations, making sure children see a wide variety seems to be a pretty important thing to do. Anything I've missed in terms of strengths and weaknesses of circles?
I mean, in my notes, I've just written P-A-H, circles, disdain emoji. But I do agree with them, particularly when you have one whole circle and then, for instance, a quarter of a circle, that's very, very clear. I mean, the one thing that we haven't discussed are two color counters, because I think they're very literal in what they represent. And I think they work particularly well within frames, like a 5-frame or a 10-frame, because then you've got that sense of the whole, which pupils will have been exploring since they were 4 or 5 years old. And so hopefully by the time you see that when you're 9, 10, you already have this established, okay, I'm dealing with something, there are parts that may not be here, and these parts are distinguished from each other by their color. Then putting those pieces together is actually, rather simple. And, we started with talking about ratio. I don't think there's anything better for articulating ratio and then modeling ratio to pupils than two color counters in a frame, because that way you can then look at what is this actually representing, what's going on here. And then I think from there, you get a really solid understanding.
Yeah, just the thing I'd add to that is the value of then using them kind of outside of the frame, because presumably, and depending on how you use them, if you're looking at inside a 10 frame, I guess this is a question I'm throwing over to you. So if, say, you were exploring a ratio like 2:1, would you use a frame for that? Because presumably a 3-frame, or would you happily kind of embed it within a 10 frame? I presume not, because of the extra confusion of that.
No, yeah, you're right. I mean, if I were to use it, I would choose carefully the numbers involved in the ratio. But it's mostly the addition, subtraction of fractions that's supported, because if you've got 2/10 plus 3/10, you've got 2 red, 3 blue, and there are 10 parts altogether, but some of them don't exist, that's where you're getting the frame benefit, So, because you're not just going to stick with the ratio of 2:1, you might have 2:1:4 by the time you're in secondary school, and then you are restricted by the frame. So if we're thinking about negatives, that frame can be restrictive in terms of number choice or question choice. So I think you're right. It's mostly for the manipulation of fractions, but I do think in certain circumstances you can utilize it. But the counters themselves as a representation of ratio are pretty powerful.
Yeah, absolutely. I mean, having those, and then like ideally having a little set spare of like, because usually if say you've got your two color counters and they're red and yellow, you've got a little pot somewhere of blue ones for when you want to look at ratio that involves kind of 3 numbers, is a useful thing to do. But yeah, I'm huge advocate of two color counters when you're talking about fraction and ratio. They're just useful for everything, really. There's so many aspects of mathematics that you just want to have a great big bucket of them in every classroom.
Yeah, when people ask me, oh, we want to get better at using manipulatives, I'll say, well, just spend a year getting to know your 2 color counters, and then the quality of experience will be immeasurably enriched. You know, it's maybe 3-4 years down the line, you start thinking about how can we get really good at using Cuisenaire, because that takes a long time, you know, and these things shouldn't be rushed, you know, and there's so much you can get from 2 color counters that I think you could spend quite a sizable amount of time just getting really good at using them.
Yeah, I know we've been here with this, but I appreciate that Cuisenaire is like the purist's choice, and that they're incredibly like versatile. I kind of think that to some extent, in certain areas, that versatility kind of works against them. With other manipulatives, there's a certain, I know what I'm doing with them. I know very specifically the purposes, and with Cuisenaire, because they can do so much. I guess you could say the same thing about 2 color counters, but 2 color counters and 10 frames, you get a really good sense of what you can do with those. Whereas Cuisenaire, it can sometimes, yeah. No, this is just me saying I haven't taught much with Cuisenaire, really. Wish I had.
I think the most important thing, though, as you say, is that if you took all of the examples that we've discussed and used them, give people opportunities to experience them, that's the main thing. You know, that's where kids build up this sort of developed schema of what proportional reasoning is, what ratio is, you know. So you can't go wrong as long as you're going past, okay, you know, because the fraction wall is very common, but that should never be the only thing you experience. As always, this won't be the last time we come back to this particular concept. It's been fascinating talking to you, Christopher. So all I said to do is say thank you very much for joining me.
Always a pleasure.
And now we're in the middle of a pretty busy time. So if I saw you in the Rhineland last week, it was great to see you. Thank you very much for coming to my session. If you're driving to MathsConf this morning, I'll make sure this is out a little bit early so you can get there, you can listen early, and I'll see you in a bit. But mostly to everyone at home, to everyone who's sponsors us on Ko-fi, who follows us in the Discord, thanks for listening. Nope. Until next time, thanks for listening. I was listening to an episode today with Kate where I messed up, and I've gone and done it again.